Alright, so let's get started with the example for recurrent neural network. We're going to see the variation of LSTM and we're going to see this on the Mathworks platform. Perfect. I'm already on the examples page of the Mathworks platform and we're going to get started with the first one called sequence classification using deep learning. So go ahead and click on it. There you go. And the beauty about this example is Mathworks allows you to run this on the browser just like a Jupyter notebook. So it has the data inbuilt and all the libraries are already imported. So all you have to do is run the code. Of course, you can make changes. You can use different functions to check and verify and things like that. So this is pretty much an active programming environment. All right, so let's get started. And you're gonna say try this example and try it on your browser. Of course, if you have MATLAB software up and running, you can also use the second option to run this example. Just give it a second. There you go. So this example is about classifying sequence into different classes. In other words, given a set of sequences, you want the network to classify it. The training will be done on the Japanese vowel dataset. So let's go ahead and directly hear it from them what they think about the Japanese vowel training dataset. So I'm going to insert a section break here and let's say help, which is the function you can call to learn more about a specific object, in this case the dataset. So let's learn about the training dataset. So once you have actually written the code, you can just run section. So this basically runs the code for you. All right, so there you go. So this says the Japanese vowels training set contains 270 sequences. Okay, each sequence has 12 features, so that'll be your feature dimension and a variable sequence length. Okay, and the responses are a categorical vector of labels 1 through 9. So this is what you want the network to classify at the end of the training. Okay, so you can learn more about the data itself by going to the sources. Perfect. Now let's take a look at the data itself. So let's add another break here and I'm going to say display the Japanese. Now since it has only 270 records or observations, you can do this. If it had more, obviously you're gonna use something else to trim the output. There you go. So this has data for us. So you have 12 feature dimensions and the actual sequences of varying length. Perfect. Now we know a little bit about the data and then you've also seen the data itself. So let's go to the next step, which is to load the data and split the data into the actual data and the labels. Okay, this is the code for that. So I'm going to say run section, and here it says the Japanese vowel training dataset, and then you load into the X train, which is the data, that is features and sequences, and then you have Y train, which is actually the label. All right, perfect. So now we know that. Now let's also check by running a display so you kind of get an idea how that looks like. All right, so I'm more interested in the labels, so I'm going to say Y train and run section. There you go. So this is just the labels 1 through 9. Perfect. Now we have a little bit more information about the data set. Now let's go ahead and plot this. This is of course built in the example. So you have the features here, you have the time step, you can study the variation. All right, next one is about preparing the data. For better performance, you're going to split the entire data set into mini batches. And since we're working with sequence data, the sequences within the mini batches needs to be roughly the same. So there are many ways to go about it, but there's another way which you can simply sort the data and then you can split it. So roughly speaking, they're going to be of the same length. Okay. Now the first thing is to get the sequence length. So go ahead and run this. Then you basically sort it. There you go. And then you can run this one. So there you go. This is the sorted version. And then you can split them into mini batches. And run this one. Okay. So this is what we get finally. This is where you actually get to define the LSTM network. Okay. The first one is you're going to define layers, and in these layers you have all these different parameters which you're setting. The first one is the sequence input layer. So this is going to be the input size of your data set. Then you have the bidirectional LSTM layer. Here you're going to define the number of hidden units, which is going to be 100, and input size is 12 as we noticed before. And then the fully connected layer, which is coming after the LSTM layer. And here of course you're going to define the number of classes, which is 9. And then finally you have a softmax layer, which is going to predict, and that's about it. That's it. Now you also need to define other things like epochs and which loss function you want to use, which optimizer you want to use. So let's get to that. So here you define the options. So first one is the epochs. Here you can change it if you like. This is 100 for now. You can of course increase, decrease. This is the mini batch size which you just created, 27. But then you're just gonna pass the options. So let me just quickly go through a couple of them. So here you have Atom optimizer, you have the CPU option, and this is the gradient threshold, and this is the max epochs which is defined here, mini batch size, and then so on. And then once you actually define the options, then finally you're going to call the train network and hold it in a variable called net. So you're going to pass the X train, which is the data, and you're going to pass the Y train, which is the labels. Then you're going to pass the layers with all the options as well. You're going to pass the layers, which has basically the information about your LSTM model. And finally you're going to pass the options, which has all the options for the network to train. Once you train, this is going to take a bit of time. So then you can test your data. The first thing you need to do is to import the test data and do a similar activity which you did to the train, which is to sort and put them into batches. And then you can call the function classify and pass the net variable, which has the information about the training. Then you pass the X test, which you just got, which is the data, and then the options along with it. Then finally you can calculate the accuracy. This is some basic match done here. Alright, so what we're going to do now is you're going to run the entire code all at once, and then we'll come back and check step by step how it did. Okay, so there you go. Let's run all. So this is going to save you some time, and of course this might take a bit of time because this is LSTM and it takes a bit of time, and this is only 100 epochs, but still you have to be prepared for some time. Alright, so I'm going to get back to you in just a jiffy. Alright, so I'll get back to you when this is done. Great, so this is done, and it took maybe a minute, I think tops 2 minutes, and that was pretty quick. So let's get to the training itself. There you go. Alright, here we are. Perfect. So you have a nice graph actually to take a look at what happened. So first of all, you can check the number of epochs here, and you can also check the learning rate here, which we actually didn't discuss. So you can also pass the learning rate, of course. And this is a nice graph with iteration and accuracy. So you can see that the accuracy is nicely growing, and it's kind of hovering around the 90 percentage. All right, so this is the loss. As you can see, this is a mirror image. Perfect. So let's go ahead and test this. So in the test, the accuracy is pretty good, which is about 90%. Great. So this is how it works with the LSTM. Now, of course, you can change the number of epochs, you can change the mini batch size, you can change the learning rate, you can pass the options here, and there are various options which you can use along with the LSTM network. This is of course a basic example, but this is a useful example which classifies a sequence. Alright, great. So I hope you got started with the LSTM examples and hope you're ready for more.